So yesterday we have looked at the problem on the generalized problem on the partial differential equation, and we have seen that the partial differential equation can be written as EBCP, NH and NHP, EBC, P, NH and NHP. Okay. EBC and P problem, as I promised, I will be able to solve it. And NH and NHP problems cannot be solved. Non-homogeneous situation, non-homogeneous boundary condition. And each of these problems can be against P to EBC and P. We have shown this is possible. That means any, in fact, NHE could not do it. Only NHP could do it. And as I said, this can be done by finite Fourier transformation. Finite Fourier transformation, that we will be discussing next. So that will be done by finite Fourier transformation. So that means any PDEs can be solved. Any PDEs can be solved, no matter what kind of boundary condition, no matter what kind of initial condition. PDEs can be solved. So if there are all non-homogeneous boundary conditions, we have to split and solve it step, and we will show that next the finite Fourier transformation is such a technique. You don't have to split even. You can directly solve. So that will be actually I will be coming later. So separation of variables, what actually I will be discussing. So EBC and P, this can be solved by separation of variables. This can be solved by separation of variables. EBC and P problems can be solved by separation of variables. For the separation of variable, I will just take one simple one-dimensional parabolic PD, that means time dependency and space dependency both will be there. And let's see how to solve a problem, heat conduction problem. We have dou u by dou t equals to dou 2u by dou x square. You can see clear cut this problem is a parabolic PD. Okay, it has got resistive term and it has got the time dependency term. The subject to the initial condition, boundary condition. So IC is given, initial condition ut equals to 0, which is u0x for example, and BC is homogeneous, which is dou u dou x at x equals to 0 equal to 0, and dou u dou x at x equals to 1 plus u at x equals to 1 equals to 0. This is the homogeneous Robin's condition. So at x equals to 0 we have the Neumann condition, and at the x equals to 1 we have homogeneous Robin's boundary condition. One is homogeneous Neumann, another one is homogeneous Robin's condition. So now this problem, if you look at, this is what category of the problem? This is what category of the problem? What is the category? Is it NHE or NHB or what is that? Is it NHE, NHB or what? What category of the problem? Big problem, yes. This is a big problem. So it is a parabolic parabolic partial differential equation, homogeneous boundary condition, non-homogeneous initial condition. So it is categorized as a big problem. It is categorized as a big problem. So, as we said that EBC or P can be solved by separation of variables. So right hand we will do what is separation of variables. If you look at this, U is nothing but function of x and t. T is time and x is the space variable. So what separation variable does, since U is a function of x and t, it says that it is possible to express this function as a product of two separate functions. That means product of two separate functions. One is the product of x function and t function. Okay. So for example, if what I am essentially doing, if I have a function called fxy, I am writing this as c of some function of x, some function of y. Say for example ax square plus bx plus c, and say ex square, ey square plus dy plus f, or q. So I am separating a function fxy, the function in x direction separately, function in y direction separately. In fact, this kind of concept, separation, it mathematically works, and I can tell you that for a large scale problem, this separation is excellent. In fact, what we do in our case, we do finite element method, and we solve the large scale CFD problem, and there we use the basis function, the product of the x function, y function, and that works excellent. So this is one of the excellent approximation in mathematics, and it works fine even for the very complex problems. So any function, if we express this way, there are some conditions coming out, and if those conditions satisfied, then the separation of variables will work. Let's look at if we express this way the function. So that means the separation of variable concept is you are actually expressing separately the function of x, separately the function of time. Here the u is the function of x and time, very complicated function, but we are separating the function x, separating the function of time, and that's why the method is called as separation of variables. That's why the method is called as separation of variables. So in that case, what we can write? We can write dou t of xx tt equals to dou x square xx tt. Correct? Okay. So what we did here? It is nothing but c xx y. Similar. Okay. Next step will be what? The partial derivative. What is partial derivative? What will be the next step? What will be the next step? If I want to expand it, what's the next step? What's the next step? X of small x dt by dt, because no will not be there. Only one variable, dt by dt. Okay. Next is t of t d2x by dx square. Alright. Next step, 1 by tt dt by dt, 1 by x of capital small x d2 capital X by dx square. This is a function of t, and this is a function of x. You can see that. The function of t is a function of x, and function of t and function of x, they can be equal if and only if I have a function x square plus bx plus c, ex square plus dx, ey square plus dy plus f. If they are equal, in that case these guys will not be there, and c and f will be same, and it is nothing but c. That means what? Equals to what? Constant. Equals to constant. So, and this constant I write as minus lambda square. Why minus? I will give the answer separately. Can you guess why minus?
It will not match up in time.
Okay, very good answer. So basically, at the steady state, if you look at this kind of solution, it should give the steady state at time tending to infinity. At time tending to infinity, this equation will reduce to what? d2 by dx square equal to 0, right? So this equation will go to, so you can see that at time tending to infinity, the parabolic PD is also merging to the ODE, ordinary differential equation. Parabolic PD is also merging to ordinary differential equation. So that kind, so if you don't have minus lambda square, we won't get the steady state solution. So based on the physics, so constant could be everything. We have selected minus sign for the constant. Okay. Okay, and since constant will be plus or minus, you have selected minus based on physics. Also, we will show there are some mathematical consequences, and we will be addressing that part later. So let's look at. So now once we fixed up the constant, once we got the constant, so what we finally got 1 by tt dt by dt equals to minus lambda square, right? This is the one part. Another part is 1 by capital X d2 capital X by dx square equals to minus lambda square, which will give us d2 capital X by dx square plus lambda square capital X equals to 0, and which is looking like what kind of problem? Which is looking like what kind of problem? Looking like what kind of problem we have discussed already? My God, which is looking like what kind of problem? What? No, we have just done. What kind of problem is given? There are so many people are bouncing around. I am not getting the correct answer. What kind of problem? What type of problem it is? We have seen this type of problem for the vector space onwards. This type of problem we have discussed from vector space onwards. What is that? Eigenvalue problem. You are very, very correct. See, I have to get the answer. For that purpose, I have to repeat 10 times my question. It's eigenvalue problem, right? That means to have the eigenvalue problem satisfied, what else you need? This is not a complete eigenvalue problem though. We need to have some other conditions. What are the conditions you need for having eigenvalue problem? For having eigenvalue problem, what are the conditions you need? What are the conditions you need for eigenvalue problem? What is that? Boundary what? You said boundary. Boundary doesn't mean anything in mathematics. Boundary conditions will be what? Boundary conditions will be what for eigenvalue problem? Boundary conditions will be what for eigenvalue problem? Vasudha? Boundary conditions will be what for the eigenvalue problem? Albeit I am telling nobody is studying anything. Nobody is studying anything in the class. For a boundary problem, so for an eigenvalue problem, what are the conditions for the boundary conditions? Without that, we cannot solve eigenvalue problem. I have discussed so many times. The class is having 61 people, and I am surprised none of you guys are actually could respond to me. What is that? Self-adjoint boundary condition. My God, I am shocked. You know some terms and putting some jargon. I can ask you how to say who said self-adjoint? Can you please raise the hand? At least I can help you. On what basis you said the self-adjoint? Because it is written in the notes. Can I explain what is self-adjoint boundary condition? I don't understand what is called self-adjoint boundary conditions. I know the boundary operator B, and B equals to B star is a criteria. Yes. See, what level I am teaching. I am surprised. Yes. Yes. See. To get the answer, at least I am getting at least one person in the class. Maybe next batch onwards, nobody will be able to understand what I am teaching, and maybe I should resign from this mathematics course from next year onwards. After 5 minutes of struggle, only one person is saying homogeneous boundary condition, and I remember that I was shouting for the homogeneous boundary condition so many times. Okay, you are preparing for GATE exam. Telling you GATE is not that easy exam. And thing is that I know how the GATE question papers will be set for this year. Okay, I won't tell you the confidential part, but I am taking the special measure for the GATE exam. I can tell you that. So GATE exam questions will be not that easy. It will be difficult, and if you don't know fundamentals, there is a problem. Some of the tricky part will be the A, B, C, D, and if you don't catch, you get the mistakes. And some of these kind of tricky points will be coming in the exam. Okay, so d2 capital X by dx square plus lambda square x equals to 0. What's the boundary condition then? Please remember the condition. See, we have solved a differential equation by eigenfunction expansion. For that purpose, we have any kind of boundary conditions, right? Last problem, if you look at my last problem of the eigenfunction expansion, how I solved the problem, and I have kept the boundary conditions homogeneous. On what basis? So what should I write the boundary conditions here? If we follow up my eigenfunction expansion problem. Pardon? How? Arbitrary you are saying, telling Basudha, you are completely gone now. You are also telling arbitrarily. On what basis? What basis I select the boundary condition for the eigenfunction problem? You look at my problems, what I did, everything I did in the class. Nobody looks at the notes even. What is that? What? How to split up? What is my, see, my boundary condition should be in terms of capital X, right? My boundary condition in terms of capital X. So that means what? We have dou u by dou x equals to 0 and x equals to 0, right? What do we write? Dou x of x t of t equals to 0 and x equals to 0. What we can write? T of t, dou of, it will be dx of x because only one variable equals to 0 and x equals to 0. T of t is non-zero. So d capital X dx equals to 0 and x equals to 0. So simple. So one boundary condition we found, d of capital X by dx equals to 0 and x equals to 0. What is the other boundary condition? 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 What will be the other boundary condition? For this eigenvalue problem, we need to have two boundary conditions, otherwise you cannot solve it. What's the other boundary problem? Other boundary condition. What is the other boundary condition? Other boundary condition? Can you derive other boundary condition? If you want to know why T is non-zero, you can write from here. T is nothing but if you integrate, what will you get? If you integrate, what you get? It's very easy. It's 10 plus 2. No constant term, no integration constant. That's the problem, you guys. C to the power minus lambda square t. And you can see that even at t equals to 0, t is not 0. Even at t equals to 0, capital T is constant, right? C to the power 0 equal to constant. So that's why I wrote t is always non-zero. For all values of t. For all values of t. I am giving so much of steps. I am telling you the last batch, last class, I have not given so much of steps. But this batch I am giving so much of step and I am getting very good outcome from you guys. Next, what is the boundary? Another boundary condition. Dx by dx plus x and x equals to small x equals to 1. Why? Because you put that x, you replace u by x and t has come out and you have seen that t is non-zero. For all values of t, based on this solution, so therefore the boundary condition automatically came here at x equals to 1. Okay, so now we can see that for a peak problem on the space, we are always getting the eigenvalue problem. So a space, so when you apply the separation of variables, you have got two equations. One is time domain ordinary differential equation. Another is space domain ordinary differential equation. And one interesting thing we found that in the space domain, the solution is nothing but eigenfunction. The space domain, the solution is nothing but eigenfunction. In that case, peak problem justifies that your boundary conditions always have to be homogeneous. That's the peak problem justification. Peak problem says that the boundary conditions have to be homogeneous. If the boundary condition is homogeneous, in that case, if you apply the separation of variables, you get the eigenvalue problem because this is the eigenvalue problem and this is the in that case, the capital X is nothing but the eigenfunction. So this is nothing but eigenfunction. That's very interesting. So the big problem, the space function x is nothing but eigenfunction. Okay, how to get this done? How to find out the x? You solve it and tell me the answer. How to find out the eigenfunction? How to find out the eigenfunction? You solve it. You know the solution. Capital XX is nothing but a sine lambda x plus b cos lambda x. Or if you write your eigenvalue problem in our usual fashion, you can write xn as eigenfunction, which is an sine lambda nx plus bn cos lambda ax. So from here you can conclude that x is the eigenfunction. Once you derive it, you can conclude hence x is the eigenfunction, write down, and lambda is the eigenvalue. Therefore, a typical eigenvalue problem can be formulated by this way. Please write this way. I am sure only two people will write, one or two. But that's my duty to tell you to write. It is your choice whether to write. Of course, you will not need for the gate exam. Gate exam only one solution. Okay? But if somebody wants to research, that's very important. This concept. Okay. What's the solution now? What is the capital Xn? What is capital Xn now? Now what are the eigenvalues? I want Xn and I want the eigenvalues. I want the Xn and I want the eigenvalues. What is Xn? What is Xn? What is Xn? Any idea about Xn? Simple, I'm just observing you guys. You guys are so genius, so much genius. The simple differential equation which has been done in 10 plus 2, people are really struggling to solve, and some people are looking at somebody else's notes. They're really amazing. I can see that. Sir, what are you doing here in the class? You are a master's or PhD? Where from you have done master's? IIT Roorkee. Yeah, maybe same thing. IIT Roorkee, IIT Madras, masters are same maybe. Do you understand how to solve this? Yeah, then why you are looking at somewhere else? Instead you can get out and give the attendance. You want that option? So, you want that option? Then you do it, otherwise I will ask you to get out. What are you doing? Close that thing, go to the last bench. Just sit that way. Collect answers, collect the book from go to the last bench. I go to the seat, step up it. And now onwards you will be sitting there only. Last, extreme last bench, and sleep if you want. Extreme last bench. Fan is also on. Now you can lie down, no problem. Okay. What's the answer? Xn. Xn, how much it is? Eigenvalue problem. What is the eigenvalue? Are you getting directly eigenvalue or something else you are getting? Something else. Tell me what is that equation? You get eigenequation. What is that? Eigenequation, what is that? My God, every point if I do like this, I don't know how I survive in this class. is the eigen equation? Equals to cos lambda n minus. That means what you get precisely? If you simplify, what you get? Lambda n equals to lambda n equals to tan. Cot lambda n. Come on, you don't even know this, huh? What is conversion for cot and tan? Lambda n equals to cot lambda n. So that means you are not getting the eigenvalue directly. How to get the eigenvalue then? From here you have to get eigenvalue. How to get the eigenvalue? How to get the eigenvalue? How to get the eigenvalue? Do you have any idea? If I have how to explain to you, I don't know. X sin x, how to get the solution? How to get the solution? X equal to sin x. No idea. Nobody knows how to get the solution. Vasudha, we cannot get solution x equal to sin x. I don't know whom I am teaching and all those things. Entire class is silent. And Amit is actually doing calculator. It don't work. It has the concept. It will work for gate exam, not for here. How to solve x equal to sin x? This is the level of you guys. I am asking questions from trigonometry and I am not going to get answer. X equal to sin x, how to get that? What is sin x function? Let me see whether somebody knows sin x function. What is sin x function? You remember in the graph? How it looks like? Wait, okay, very good. We know sin x function. This sin x. And what is, so that means this you can write as y equals to x and y equals to sin x. And y equals to x is this graph. That means this is the point, it is touching. So this is the solution for x equal to sin x. Why it was not, I was not getting so simple. Y equals to x and y equal to sin x. Draw the graph and graphically you get the solution. Right? Then what is the solution for lambda equals to cot lambda n? So you can write y equals to lambda n and y equals to cot lambda n. What will be the x-axis then? Your x-axis will be what? Lambda n. This is your y. How the cot lambda n graphs look like? Do you remember? It is like this. Okay? If you don't know, if you can look into it. And this is y equals to x graph. So you can see these are the roots. And these are the eigenvalues. These are the eigenvalues. This is your lambda 1, lambda 2, lambda 3 and so on. Okay? So these are the eigenvalues. So how to find these lambdas then? It will be very difficult for you to find out from the graph paper. How to find the lambdas? How to find the lambdas? Any idea how to find lambdas? If the graph paper is not there, then Amit will say I will find my calculator, parallel method. Okay? But that is not acceptable for the exam. So you will do by Newton-Raphson method. What is Newton-Raphson method? Do you remember? What is that? Some formula will tell. Can you derive the formula for Newton-Raphson method? No way. I can wait. We cannot derive the formula. Can you derive the formula for Newton-Raphson method? Taylor series. Very good. X nu equals to x whole minus fx whole by f prime x whole. This is the formula for reduction method. So lambda n equals to what lambda n? Okay. So getting the roots here. Where are the values? So basically what you have to give. So you can see that there are values actually around and nearby. So what you can see that the cot lambda n is nothing the x-axis, right? So that could be a good initial case to get this solution. So for which values cot lambda n equal to 0, that you can find out. Cot lambda n 0. For what lambda n? That means cos lambda n by sin lambda n has to be 0. That means cos lambda n equals to 0. What is the value for lambda in that case? Lambda n equal to 0. Cos lambda n equal to 0. In that case, what is the value of lambda? 2n plus 1 pi by 2. 2n plus 1 pi by 2. So that is the initial case for the introduction method. That means what? I want to find out lambda 1, for example. So this is the function of, so what is my algebraic equation? Lambda n minus cot lambda n. This is my equation. Right? For the first eigenvalue, lambda 1 nu equals to lambda 1 whole minus f of lambda 1 whole by f prime lambda 1 whole. Lambda 1 nu is there. We have to, lambda 1 whole is what? 2 plus 1. N could be equal to 0. If you want to find n equal to 0, what is the value of that in that case? So by the way, what is the xn in that case? I am going to decide whether n equal to 0 is acceptable or not. What is the value of, what is the xn? You have not told me the xn. I was directly doing the lambda n. You have to tell me the eigenfunction also. What is xn? Can you tell me quickly? Bn. That is not eigenvalue. This is the initial case. Come on. I don't know what I'm understanding there. Is it eigenvalue? Of course not. Eigenvalue has to satisfy lambda equal to cot lambda n. This is the initial case. I said initial case. This is not eigenvalue. This is not eigenvalue. My God. This is not eigenvalue. It cannot be eigenvalue. It has to satisfy lambda equal to. I have drawn the diagram, no? Then why you are saying that lambda 2n plus 1 pi by 2? This is a diagram. This is not eigenvalue. So for the lambda 1 whole, so that means even if you put n equal to 0, my initial guess is pi by 2, right? And n equals to 0 somehow you can actually get because it's already cost function. Okay? So n equal to 0, even if the eigenvalue is near to this, my eigenfunction will not be 0. If it is sine function, is a problem. N equal to 0, right? So in that case, what actually happens? Lambda 1 whole initial case is how much? Pi by 2 minus f of lambda 1 whole, which is pi by 2 minus cot lambda n is pi by 2. My derivative is 1 minus, what is the derivative of cot lambda n? ddx of cot x is nothing but minus cosec square x minus cosec square pi by 2. You got lambda 1 new value. Then again you iterate. So I think some of you in the class, maybe Basuda or Kabia, can actually do it together to find out the eigenvalues and give the final solution. Maybe on Friday, Thursday your exam is over, Thursday night you can do it. Okay? So you get the values of lambdas, maybe set up 5, 6 values or maybe 10 values. You can do it by this method. What you can do that, one set you can do by hand and then you can go to MATLAB. MATLAB can do it very fast. You do it in MATLAB and MATLAB can give you the answer. But every eigenvalue, that is the initial case. Or if you do it by calculator, it can do only 1 or 2 iterations. Very fast you can do it. Understood how to find the initial guess? So initial guess, what I am actually doing that initial guess, I am putting cot lambda equal to 0. That means somewhere it is touching here. I am saying that if I give initial guess, then I will get the solution here. So basic introduction method says that if your guess is near to the solution, you can get the particular solution. Or if you give arbitrary solution, you may miss lambda 1 or some lambda 2 can be missed out. Okay? So this is the way. So similarly for the lambda 2, the initial guess will be 2 into 1 plus 1. Right? That means 2 into 1 plus 3 pi by 2. So lambda 2 old, first guess, initial guess will be 3 pi by 2. Lambda 3 will be, initial guess will be 5 pi by 2. 2 into 2 plus 1. Lambda 4, lambda 4 and so on. That is the way all the eigenvalues have to be calculated by introduction method. This method is not discussed in any of the books. Some of you might be thinking, okay, I want to learn. Fine, that will be missing out on the books because none of the books discuss this lucid way how to find eigenvalues for this from this eigenequation. Okay, so you got the eigenfunction, which is xn equals to bn cos lambda n x. Okay, what's your final solution then? Your final solution u xt is nothing but capital Xx t. Am I correct? Yes or no? How many eigenfunctions you get? Infinite. You get infinite eigenfunctions. N equals to 1 to infinity. Or you can say 0 for here, so 0 to infinity. So there are infinite eigenfunctions, right? There are infinite eigenfunctions for this. That means this x solution, this x can be written as a linear combination of infinite eigenfunctions. This x can be written as a linear combination of infinite eigenfunctions. That means my solution could be written as x1x dt plus x2x dt, and we have xnx dt. It will go on. That means we will get summation xnx dt. That is your solution. That's your solution. Am I correct? Okay? Yes? So uxt we can write as summation n equals to 1 to infinity. Xnx means bn cos lambda nx into c e to the power minus lambda n square t. Okay? So each of these will have the, so I should write t1t, t2t and tnt. Remember that tt is given as c e to the power minus lambda square t, but there are different lambdas, lambda 1, lambda 2, lambda n. For each of these cases t1 will be changing, so t1 will be c1 e to the power minus lambda square t, t2t will be c2 e to the power minus lambda 2 square t, and so on. So it will be cn. So what you will get? N equals to 1 to infinity, bn and cn will become dn cos lambda nx e to the power minus lambda n square t. Am I correct? Yes? How to find dn? If you find dn, you get the answer. That's the solution, uxt. But to find the dn, if you find dn, you are done with. How to find dn? How to find dn? Initial condition. What is that? ux0, which is u0x given, right? That means u0x is nothing but summation n equals to 1 to infinity dn cos lambda nx e to the power minus lambda n square t equals to 1, which at t equal to 0. And this cos lambda nx the eigenfunctions and the self-adjoint operator. The eigenfunction of self-adjoint operator is always orthogonal. That means what? How to find dn then? dn equals to, how to find dn? This is written written this function of x is written as a linear combination of eigenfunction. How to find the inner product? u0x cos lambda in x, then divided by cos lambda in x, cos lambda in x. Okay? That's it. So based on the values of u0x, if I take the values of u0x, we can integrate this, you can integrate this, you have done all those eigenfunction expansion, and you can, and then once dn is known, you got the final solution. So that's the overall procedure for the separation of variables. So this is the overall procedure for the separation of variables. So what I want you to do that, I want you to find those set of eigenvalues and give the entire procedure. Okay? That will be a very interesting exercise for you guys. Next, I will be going to the two-dimensional problem for the parabolic PDE, and that will come up for the elliptic PDE as well. Because as I said that parabolic PDE will be converted to elliptic PDE at time t tends to infinity. Similarly, time t tends to infinity, parabolic PDE will be converted to ODE if dimension is one dimension. So I will not discuss separately the elliptic PDE. I will be discussing now higher dimension parabolic partial differential equation. So we will be talking about parabolic we're talking about parabolic PDEs. So, higher dimensional, dou u by dou t, which is grad square u, which I am assuming here dou 2u by dou x square plus dou 2u by dou y square. Initial condition, which is u t equals to 0 as function of xy. Boundary conditions, u x equals to 0 for all y, which is gy, u x equals to a for all y equals to 0, u y equals to 0 for all x equals to hx, and u y equals to b for all x equals to, I can tell this is 0 and this is equal to hx. So what is look like? I am trying to solve this differential equation dou u by dou t in this domain. This domain length, this is A. This domain length, this is B. Correct? X equal to 0 to A, y equals to 0 to B. Now can you tell me geometrically what are the boundary conditions? At this surface, what is the boundary condition? At this surface, what is the boundary condition? G of y. At this surface, boundary condition. So u equals to g of y. U equals to, here u equals to 0. Here u equals to h of x. And the initial condition for the entire domain, which is function of xy for all xy. That means at each point it is function of x and y. Initial condition. This is the entire problem. This is the most generalized problem. I will not solve separate elliptic problem, because if you solve it, you can even solve the elliptic problem. Because this equation will become elliptic if dou u by dou t equals to 0 at the steady state. So that's what this is the most generalized problem. So how to solve it? How to solve this problem? How many sub-problems? This is not a big problem though. Why it is not a big problem? Because boundary conditions are not homogeneous. So not a big problem. So that means in that case you have to split up. In that case you have to split up. How many sub-problems will be there? How many non-homogeneous are there? How many non-homogeneous are there? 3 or 4? Are you sure 3? Okay. Why 4? Who said 4? The equation is non-homogeneous. Are you crazy? I think you are forgetting mathematics now onwards. Is it non-homogeneous equation? What's the operator? Yeah, I told you that if you want to find out If it is homogeneous or not, you always try to put in a du equals to f, and f is not the function of u. I think you are becoming crazy now. So it is, well, so if you look at L is dou by dou t minus grad square is operator. It's quite obvious, it's homogeneous partial differential equation. So you have u1 plus u2 plus u3, the sub-problems. You have got 3 sub-problems. So I will finish it here in the class. So next class I will start in from the sub-problems and I do it. I think this Wednesday I need your time maybe at 2:30. Can I